introduce Siri Jodha Singh Khalsa. Now, Siri Jodha has really been with us for a long time at NSIDC. Now, before he came to NSIDC, he was doing things like boundary layer turbulence and things like that, but came to us really in 1983 working with the DAC on many different areas of product support, data support, all sorts of things. But he's gotten very, very interested in things like data standards, right? The underpinnings of science. Someone told me once that the wonderful thing about standards is there's so many of them, right? But I suspect that perhaps Siri Jodha has a different view on that. But it's really great to have you, Siri Jodha. And so we're going to hear today about the importance of standards in science and society. So without further ado, take it away.
Thank you, Mark, for that introduction. So I'll just jump right in. And how I'm going to do this is really start out with a personal story about how I came to be involved in standards. I'm also going to touch a lot on not just the work with the DAC, but things that led up to work with the DAC. I'm going to talk about standard development a bit, how they're created, and then I'm going to talk a bit more about the geoscience remote sensing standards work that I help happen, and then talk about conclusions and future events. All right, so as I said, I'm going to kind of a personal story, and as Mark said, I started out with a PhD in boundary layer turbulence, applied to air-sea interaction at a postdoc at the University of Hawaii, started applying satellite remote sensing to look at air-sea interaction, and that was with NOAA's Climate Research Division, which brought me to Boulder, Colorado, on an NSC fellowship. And that, as I will describe or allude to, led to cryospheric applications at NSIDC. So I'm going to kind of present this as a timeline. So NASA's EODIS courses and ECS, I was hired as the science liaison assigned to the snow and ice DAC in 1993. And I went to work for the science office and began, part of that work was on the ECS data model. Back then it was called Mission to Planet Earth Observing System, and the prime contractor was Hughes Aircraft. Then in 1997, the science office published a white paper on metadata. It was the ECS data model for data provider guide to metadata. So this was to bridge the gap between the detailed schema and that was in hard access documents for the layman or the instrument teams are really what this paper was targeted at. And I was going around presentations to the MODIS and other science teams on the planned EOS platforms and giving like high-level overview. We decided there needed to be a more detailed view that that provided the necessary information about how to populate metadata with and what the fields are expected and the description of them then was available or accessible in other documents. All right. So then, well, of course, then in December 1999 was the launch of the first EOS platform called AM1 then, and now called Terra. But in 2002, there was a special session on data services and tools led by Roger King and Rich Ullman. Roger King was the chair of the Geoscience and Remote Sensing Society's Committee on Data Standardization and Distribution. And at the end of the meeting, they passed around a sign-up sheet for the committee. And I thought, well, I kind of want to track what's going on there. I thought it'd be important. So I signed up. In the presenters at this session was also someone from the ISO TC211 Secretariat, Olaf, and then Paul Smits, who worked for the European Commission Joint Research Center and leading the INSPIRE adoption of metadata. And you'll see Raul Ramachandran talked back then, and Rich Ullman, again from NASA, who's all working in USDIS. So that was 2002, and that had a number of consequences down the road. So, but first I'm going to talk about NASA SEEDS. That's the Strategic Evolution for Earth Science Enterprise Data Systems, and they produced a paper in 2003. I wasn't involved in that, but the important point was they recommended ISO 19115 as the metadata content standard for EOSDIS. All right, then in 2000, a year later, since I had signed up at the IGAR symposium for the Technical Committee on what became the Data Archive and Distribution Technical Committee, I was asked to be the Geoscience and Remote Sensing Society's named expert to the project team writing the extensions to 19115 for imagery and gridded data. I brought some experience since we've started work on the NSIDC GLIMS database, as well as the ESOS D0 data model to that working group. Then I'll mention, since we're, oh yeah, there's part 2 that was published finally in 2018. All right, so Digio Architecture and Data Committee. So in 2006, the Architecture and Data Committee formed. I was present at the inaugural meeting, and one of the things proposed there was that there should be some way to some body to review and advise on standards and interoperability for the Global Earth Observing System, GEO being the intergovernmental group in Earth observation. So I created and chaired that Standards and Interoperability Forum, the SIF. The Open Geospatial Consortium, another standards development organization, was also a big participant in the Architecture and Data Committee and the creation of GEOS by leading the architecture implementation pilots. And then I'll say that part of the infrastructure that was developed for GEOS was a broker, a mediator, a software that would allow the different space agencies or other providers of Earth observation data, which included NASA, ESA, JAXA, and other organizations, DLR, and what have you. They all provided data, but through different protocols and following different standards for metadata. The broker was designed to mediate between those and present a unified access, discovery access through a common data model to those data sets. All right, GEO, which was, the theme was information for the benefit of society. It had at that time these societal benefit areas. All right, okay, so in 2010, I made a presentation to the DAC managers on the Federal Geographic Data Committee's content standard for digital geospatial metadata, the FDC CSDGM. And the reason for this is that there was a federal mandate that the federal agencies should adopt the FGDC standard, the CSDGM. And so I'll show, this is one of the slides from that presentation, and it sort of showed the lineage of geospatial metadata standards. So the CSDGM helped inform the ECS data model as well as the original ISO 19115. There were these extensions for remote sensing data that was informed in turn by the ECS data model, and then became a basis for 19152 The ECS data model, fed into the ECHO data model. But what you don't see is the ISO standards feeding back into the ECHO data model, because that had not happened yet. And the degree to which it would happen was open to question. But I'll say that all FGDC sort of eventually acquiesced to 1115. They created a profile of 1115, so it essentially became the default standard, and CSDGM was withdrawn. And I'll say not all standards even get adopted before, or get widespread adoption before they're retired. And the spatial data transfer standard, the SDTS, is a good example. Again, it's federally mandated, but agencies didn't really follow it. The tools weren't built to support it, and it was eventually withdrawn. Okay, so jumping forward a decade to bring it up to near present, the ESDA Standards Office, which had been an outgrowth of this SEEDS project I mentioned in the previous slide, SEEDS spun up a standards process group, and I was involved with that at the beginning, defining their governing documents and procedures. And it eventually evolved into the ESDA Standards Office, and I've gone back to working directly for the Standards Office. It coordinates reviews and leading to endorsements of standards for NASA's Earth Science Data Systems. MENS. Aha. Somehow, I skipped past the MENS Tiger team. Metadata Evolution for NASA Data Systems. I led the Tiger team that produced this paper, in which we made recommendations for ways to adopt the 19115 metadata standard for EOSDIS. So I'll leave it there because it didn't really come out like we expected. In any event, other standards related activities I'm going to briefly mention. Let's say I'm only 15 minutes into the talk, so that's not bad. But I could spend a lot of time on each of these. Instead, I'm going to go over them relatively quickly. The NASA Earth Science Data System Working Groups, the ESDSWG, has been around for at least a decade, I believe, and I've been involved in several of those. The Federation of Earth Science Information Partners, which you might have heard of, ESIP Federation, does a lot of standard-related things. The Research Data Alliance, being more global, the first two being well, certainly starting out as U.S. specific, but RDA is global. I'm going to talk about the NSF EarthCube Cyber Infrastructure Project, and then I'm going to mention some European projects that I'm involved with. All right, the SDSWGs, probably the most relevant one is the Dataset Interoperability Working Group, which has been going for at least 5 years. I didn't look it up, but I've been involved from the beginning. It makes recommendations on standards and other community-based guidance to the as a standards office. And right now, one of the things being worked is under the DIWG is conventions for machine learning training data sets. Then the other one that bears mention, because it's consumed a lot of my time over the last few years, the Data Product Development Guide for Data Producers, the DPDG. That's also going through an approval process in the ESDA Standards Office. That is meant to assemble all the recommendations from the DACs and from the DIWG into a single document to help data producers who are producing products that will become part of the EOSDIS ecosystem, produce things the way that NASA would like to see them and maximizes the benefit for the user community. The ESIP Federation, it does studies, makes recommendations. It's not a standard setting body, but they have representatives from all the federal agencies, NOAA, USGS, NASA. An well, current example, schema.org, okay. This is obviously about data discovery and best practices for using schema.org markup, structured markup in website landing pages to make them discoverable through crawlers like Google. The Preservation and Stewardship Committee of ESIP produced a provenance and context content standard. I came to ESO for endorsement, and then it was actually carried all the way through by Rama, former USDIS lead scientist, not lead scientist, I forgot his title. He actually took that to ISO TC211, which I'll talk more about, and got it international standard. With some, obviously some modifications with those space agencies weighing. And then there's a lot of synergy with the Research Data Alliance, a lot of parallel activity between the two, which I will talk about next. Again, very briefly, the Research Data Alliance is a global organization of stakeholders involved in seeing that research data is, well, a lot of it has come down to what's now called fair, findable, accessible, interoperable, and reusable. But I'll mention my role was participated in a brokering interest group. So the broker was what was used in GEOS to mediate between different protocols for discovery and access. We brought that to the Research Data Alliance and came up with recommendations. So the RDA is very results oriented. The working groups, the interest groups are meant to initiate working groups that have 18 months to come up with an output. So the working group, and we made recommendations on brokering, how to build a successful broker, build and utilize a successful broker. And then 2016, I helped form and then co-chaired for up until this year, the Data Discovery Paradigms Interest Group. And we actually spawned working groups on data granularity. And we also have one on structured markup, i.e. schema.org that's working in parallel with ESIP. And then just to mention, since FAIR is a big part of what the buzz nowadays about making data accessible and all the things that NASA would like to see. They're working metrics. There have been metrics to assess how fair a data set is or how fair a data repository is that overlaps with the repository certification, but I won't go into that. EarthCube, NSF EarthCube. This is, I think, at least 10 years old. An initiative between the Geoscience Directorate and the cyber infrastructure. Forget the name of the directorate, but with the intent to bring computer scientists and geoscientists together to collaborate on building a cyber infrastructure for all the geosciences. And this was meant to be thumbs up. They weren't going to make big grants, huge grants like NSF tends to do for infrastructure building. It was meant to be from the bottom up. So again, I got a pretty big grant that involved 5 institutions to lead a brokering project that, again, leveraging what we learned in GEOS. But one thing we did learn there was that people would say they have an endpoint that follows this metadata standard using this protocol, and the data is accessible via this web service. Well, it turned out there were often lots of flavors of those services, and we'd have to tune the broker to each individual service in many cases because of the looseness or the improper interpretation of the standard. So it was a key lesson learned. Then I'll also say that before NSF EarthCube, I was part of a NS interop project called the CICE initiative, and that was all about semantics for CIs. And semantics is a whole nother topic that I don't have time to go into, but that also is important for interoperability. European projects, two I'll mention that I'm involved with, and they're related. I was asked to support analysis of possible pathways for bringing community-endorsed best practices as they relate to ocean observed into the standards development process. So showing the web page of oceanbestpractices.org, I believe it is. And you can see it's a large repository, 423 documents describing best practices. And then I presented at a workshop on what the process was to get a community-derived or otherwise, existing specification or practice into the standard development process. And then leading out from that is the CAPARTIS project, another EU-funded project that's developing Arctic practices system that's going to build off of the OBPS. And that is focused a lot on community monitoring and indigenous knowledge. And Noor Johnson of NSIDC is also involved, as is Peter Pulsifer. So I won't say more about that, but I will then mention the European project that I'm involved with. It was, gosh, probably 5 years ago that I was seconded. I was requested by WMO to support, to help oversee, not really oversee the development, but just advise on the YAP data portal that was being developed by the Met Service of Norway. So I've been doing that for those 5 years. I'm on their committee. But really what I focused on is the semantics for these NetCDF formatted files that are part of YAP supersite intercomparison, supersite model in comparison. I forgot the M in there. It's important. MIP. It's the YAP site MIP, where we're trying to get all the observing systems to produce these NetCDF files, and all the model outputs, the high resolution subsets around the supersites to produce outputs in the same NetCDF format, using the same terminology for their variables, so that it's easy to build tools that'll compare observations to models. And this is being done with NOAA's PSL ISOA project. And Mosaic was added as one of the YAP special observing periods. And so that data is getting in there too. All right, that's an overview of the course involved with. Back to a presentation I made in 2018, to the Cryosphere Processes, called Global Needs to Broaden the Benefits of Research to Society. And I had kind of this roadmap of the things I was involved in was going to talk about. So hopefully what I just presented is a little more coherent than what you might be able to derive from this. But I didn't talk about Arctic Data Committee, but you see the Group Earth Observation Standards, the whole, Research Data Alliance, NSF, and then the DAX, and then the IEEE, but I guess some things never change. All right, here we go at 26 minutes. Why standards are important. What are the different types of standards, and how are they made? So we don't have to belabor that. It doesn't takes only a moment to realize the extent to which standards underpin much of the science endeavor, and really they enable life as we know it. Beginning with weights and measures, obviously, all the devices you use, everything in them about their manufacture and their operation depends on standards. Communications, IEEE 802.11, that's what makes you connect the Wi-Fi wherever you go. Email and the internet, of course, wouldn't be possible without agreed to standards. And programming languages are also standards that are produced by standards bodies. All right, there are many kinds of standards. Obviously, they're very informal standards. Everybody just agrees to do something a certain way. There are community standards where a community really does converge on a way of doing something. They develop specifications for it, and everybody just sort of follows it. Those become, and then there are standards that actually might be developed by not an open process, but they become de facto. So like GeoTIFF, right? That has been submitted to, maybe it's finally an OGC standard, but for decades, everybody used it, but it was just an extension to an existing private proprietary standard TIFF. I think it's proprietary. But NetCDF and then the spatiotemporal asset catalog stack, a very recent standard, they're all examples of the community developed de facto standards. And then, of course, there are profiles and extensions of existing standards. So you can take a standard, create a profile of it, extend it a bit, and make it a new standard, and that can or may not go through a formal standards process. All right, more to inspire you about standards. INSPIRE is the infrastructure for spatial information in the European community. It's kind of a cornerstone of the European experiment in trying to get countries to agree to do things in a similar way for the sake of peace and prosperity. The flow of goods and people and information, and are very important for the latter. So it's law. INSPIRE is law in the European Union. There are sections on metadata and interoperability of spatial data sets and services. The UN Sustainable Development Goals, the chart is analysis done by GEO showing the Earth observation assets that can address these goals, and then each of them, the reporting standards and the observing standards, are all essential to that. And then even the private sector publishes on mobilizing the data revolution for sustainable development, again underpinned by standards. This actually is a slide from my presentation in 2018, as is this slide, open science. So I was talking science in 2018. Now it is a big deal. NASA is really coming down on the need to do this. If you look at this open science life cycle, you can see how much standards become important. In fact, at the preparation stage, getting funding, agencies all require the data management plans now, and they're significant. And the Research Data Alliance has made standards for generic data management plans and ways to make them machine readable. Okay, but most of these things, these facets of the open life cycle, are underpinned by standards. Then this is fun. 5 Week is going on right now. That is from the European Space Agency. And this talk was just a couple of hours ago. I did a screenshot of Ingo Simonis of OGC talking about their common API and how that all fits into an ecosystem of bringing services to data in the cloud. But he's showing the cycle there, and on the right, at that moment he was talking about standards and protocols, and lists Open API as an example, stack and what have you to make these components in this ecosystem reusable. And then ethically aligned design. And I'm bringing this up because it's something that IEEE is Association is involved with their P7000 series. And just to give an example, there is a group working on algorithm bias, how to identify and correct for algorithm bias in machine learning. There is a group on metrics for well-being, human well-being, how to assess whether humans are being impacted by AI or not. There is a group on the process for identifying and rating trustworthiness of news sources. So IEEE isn't just about technical standards. It gets into ethics also. Standards development process. So ISO, which I assume most people are familiar with, the acronym at least stands for International Organization for Standardization in French. So the way standards are initiated there is that at least 5 national bodies have to get together, agree that a standard is needed, and then bring a new work item proposal to ISO for voting on amongst the voting members of the particular working group that it's brought to. Technical committee that it's brought to. And so the work is done by representatives from national bodies, but also by liaisons from organizations like the OGC, IEEE, WMO, W3C, CIOS. These are all organizations that have liaisons to ISO Technical Committee 211 on geodata, on geospatial information. IEEE Standards Association is an example of an industry and trade standards development organization. OGC is an example of a consortium, which of stakeholders, and it tends to have a more narrow focus, geospatial, obviously, in that case, whereas IEEE does a lot of different things. So while there are various motivations and routes for initiating standards development, the process is similar across standards development organizations, and that they provide policies and procedures to ensure due process, broad consensus, transparency, balance, and openness. And it's not about finding the best technical solution necessarily, but it's about finding the best consensus-driven solution in which all participants can live with. And then standards typically define what an implementation of that standard must do in order to declare conformance to the standard. And this will become important when I talk about the GRSS projects. All right, you'll hear sometimes standards development being described as bottom up versus top down. This doesn't really represent it very well, because a community need can be taken to an SDO to initiate a standards development process. So an SDO can facilitate creation of a best practice, but it's codified and it's developed with stakeholders at the table in an open, transparent, consensus-based manner. Or an existing community practice can be submitted to a standards development organization for formalization. So those are bottom-up becoming formal standards, and really, it's not like a bunch of standards designers, decide, let's make a new standard. It all comes from a need somewhere. All right, so finally, in the next 10 minutes, I hope to acquaint you with what I do with the GRSS Standards Committee. So it was formed in 2017 at the request of the president of GRSS, the Geoscience, the IEEE Geoscience and Remote Sensing Society at that time, and he asked me to lead it. And the goal is to develop a coordinated suite of standards that covers all aspects of geoscience remote sensing technologies, including the sensors, platforms, operations, processing, and information extraction and application derived from those platforms. It really seeks to foster a connection and collaboration between academia, which the GRSS is heavily represented in, federal agencies, and the private sector. That was one of the motivations for starting the Standards Committee, because there was kind of a lot of academics. You had some space agency representatives, you had some private sector, but they really weren't working together on things. Excuse me, and standards was a way of, seen as a way of doing that. So currently I'm the chair. The former chief technical officer of OGC is the vice chair, and a Maxar employee here in Colorado is the secretary. So I'm going to walk you through the projects. The first one, characterizing and calibrating hyperspectral imagers. This is a really active group. They've been working at it a couple of years. I think it's like 243 interested parties in the main list, and about 40 to 50 show up at each meeting, main meeting, so they're voting members. And then 3 subgroups on terminology, characterization, and metadata. And those hold their own meetings, sometimes weekly. So it's defining features and terminology for the absolute characterization of hyperspectral imagers. So the interesting thing is, you've got a lot of stakeholders at the table. And a lot of those are manufacturers of hyperspectral cameras. And they want a standard so that there's a level playing field. And when somebody says, my camera does X, Y, Z, it should be traceable to a standard. And that's what this is attempting to do. And there's a lot of back and forth, and sometimes the discussion can get pretty heated. But it's moving forward, and there's a draft out now, and they hope to have a draft ready for balloting at the end of the year. An example of the back and forth was it took them a half a year to agree on the definition of hyperspectral imaging, and came up with a minimal viable definition that was prefaced with for the purposes of this standard. And then it goes on to say what a hyperspectral imaging system, what its characteristics have to be called hyperspectral. I'm really sorry. Give me one more moment to take a drink. P4002 is a metadata file for synthetic aperture radar data, and it arose for the need to support generic tools for processing our data. So that they could work with data from multiple sensors having different formats and configurations. So at one point, the National Geospatial Intelligence Agency got wind of this because they have a standard called Sensor Independent Complex Data, SICID. And up to that point, we've been working mostly with extending ISO 211 standards to describe SAR data. But NGA came in and said, well, we already have this standard. And now the work really is in merging those two. 4003 was describing GNSS reflectometry data sets, and that's Cygnus, image of the Cygnus constellation on the left. This is remote sensing using signals of opportunity from GNSS satellites. And the drafting team was composed almost entirely of academics with a few private sector folks who build small sats to do GNSSR. And they managed to produce a draft for balloting in just 2 years, despite the fact that the initial leader had to resign. So this is definitely a success story. It is approved by the standards board at IEEE and should be published sometime before the end of the year. The successful story is about P4004. It started off with a lot of interest. We had a meeting at IGARS years ago. That was the one in Yokohama. And just all the players showed up at a side meeting we had to kick this off. But the leader, who was a postdoc from who had graduated from CU engineering, had to move on. He couldn't devote the time to it, and while everyone was interested, no one wanted to take the work up to move it forward. Meanwhile, a Chinese academic brought a similar project to ISO TC211. This was someone who had been on the P4000 team, and resulted in them moving through TC211, a standard from the calibration and validation remote sensing instruments version 4 for spaceborne microwave radiometers. Call for and scheme for measuring soil spectroscopy. This again, a lot of interest, a lot of interested parties from around the world in working on this. because there's a need to be able to combine the soil spectral libraries that have been developed by different countries and different agencies. But if protocol for acquiring them isn't consistent, then that's difficult to do. So that was brought to GSS by a professor at Tel Aviv University who had published on this topic, and working forward under several working groups for lab versus field, thermal versus SWIR, that kind of stuff. The most recent committee we have is remote sensing frequency band impact assessment of radio frequency interference. This was initiated by the GRSS frequency allocation remote sensing committee. It has NASA and ESA involved, and they just kind of had their kickoff. They were delayed by COVID, and they had their kickoff just earlier this year. All right, potential future efforts, analysis ready data. This whole thing about how to essentially data quality, how to codify what the quality of a product is for data vendors, space agencies. I'm giving a talk at an analysis ready data workshop in next week or two on past standardization of the efforts primarily coming out of CIOS, but also European Union. We have representation on the Spatial Web Protocol Working Group. This is the IoT, all things spatial, interconnected, spatial Internet of spatial things, right? Sample mark language for machine learning is something being done in OGC that we might have some involvement in. I'm saying we as the GSS Standards Committee. And then P, 1952 is kind of far field, but we're tracking it. It's resilient positioning. It's resilient user equipment that uses PNT, GNSS, satellite data. That has a lot of Homeland Security folks and Defense Department and stuff, but it does tie a bit into remote sensing, so we're tracking it. All right, my conclusion slide. Well, standards make life easier, safer, and more predictable. You might contest easier, but if you stop to think about it, it enables more things than it inhibits. The important ingredients for a successful standards development project is committed people, obviously. It's a long haul, good leadership, and then policies and procedures to ensure fairness and balance. People get involved in standards development for various reasons. We've seen a lot of people doing it to enhance their market position for their products. But a lot of people do it so they can work at the leading edge of the technology. I'm learning a lot about hyperspectral imaging. I thought I knew something about hyperspectral imaging, but the details are sometimes fascinating about how the cameras work. All right, and then people contribute just to see their contributions, their what they've been working on, get into something that's adopted internationally. And then people get involved for humanitarian reasons and more. So that's the end of my talk. Contact me if you want to learn more about how you can become involved, or if you just want to stay informed by signing up for one of the mailing lists of the committee or any of its working groups. Thank you very much.
All right. Question for Siri Jodha.
Siri Jodha, this is Twyla. Thanks so much. It strikes me from your talk that so much on standards and data is really quite new, and there's a lot we're catching up to all the aspirations of data creators. And I'm curious, in navigating all of this ecosystem, if I'm kind of sitting at my desk and I'm imagining I'm going to create a new data set, what is your recommendation as kind of the first place I start by deciding where I might archive it and going to information from that group, or starting more with maybe an umbrella group for our field, or what makes sense as an entry point as a person's deciding about what their data will look like and how they'll put it together?
That is a really good question, and the options you mentioned are all possibilities. So it depends. So knowing who's going to archive your data obviously is a very good first step, because the archive will have policies, obviously, and guidelines. Some detailed, maybe not, some not detailed. If you're at all involved, so I would say that the Data Product Developers Guide that NASA produced is a great place to start, because it's generic to a degree. I mean, the factors that to take into account about your user community and how to go designing and testing and getting feedback on your product are all spelled out there and kind of apply universally. So then, of course, the community, and then there's what have similar data sets used, right? And that, so I mean, there's, about data, there is the data encoding itself, what format to use, and the CDF, HDF, binary with metadata file. It's what tools your target community uses, and what it can work with, stuff like that. And like I said, all these considerations are spelled out. And a shout out. Oh, I don't hear anybody.
We lost you for a minute.
Oh, well, that's not surprising. That's my internet.
You're back.
Was there another question? Was there another question?
Out it out if you got it. Anyone else?
I want to give a shout out to Luis, who alerted me to that Ingo Simonis was talking in the 5-week, ESA 5-week. So I even another meeting at the time, I fired it up and got that screenshot.
Well, I have to admit, this is Twilight again. I have more questions. Maybe this is never a surprise. I am wondering, Siri Jodha, because I'm thinking as folks are trying to increasingly create connections across disciplines, what different kind of levels of topical data coordination do you end up seeing happening? Is there much attention to sort of, what's happening over there in health sciences and what's happening over there in, et cetera, this kind of like, other disciplines that might eventually be able to assist with those folks' data communicating with each other down the line, or if people kind of end up circling off into their own zones.
Silos, we call them. Anyway, another really good question, and that is exactly what the RDA attempts to address, because you have the health sciences people there, you have the material scientists, you have the chemists. We had news organizations in the early days. I haven't seen them much recently, but everybody who's like, trying to find data, trying to use data, and sharing the lessons they learned, and convening groups to look for solutions to their common problems.
Hi, Siri Jodha. This is Luis. And
Others?
so, well, this is very specific for NSIDC data, but has there been like any initiative to kind of modernize the standards on which the data it's encoded for data holdings? So what I mean is, like, right now, all the data, it's in HDF for the most part. And with the cloud age, there are other formats that might be more like optimal for the new access patterns. And
Exactly.
that's big, right? Because it's not like trivial to transform petabytes of data into a different format. But what is the position within NASA towards that kind of work?
These all seem like planted questions, folks, because they're really good questions. So as the standards office that I'm involved with initiated an effort, asked Chris Linus, the OSS architect, asked the standards office to write a white paper on cloud optimized formats for point cloud data. And we have a white paper in preparation there, and so that looks at all the options for the data formats itself, like the legacy formats, and then the how they're served in a cloud environment, and how there may be the content might be reorganized to make them cloud optimized. So there are going to be recommendations coming out of that. Even though we didn't have the resources to do trade studies, we looked at ZAR, TileDB, end-to-end point tiles, different options for point cloud data, with some experiments, specifically with ISAT data, ISAT2 data. So yeah, as data moves to the cloud, the actual storage format becomes the native storage becomes less important, and how it's organized to make it cloud optimized, or supporting an analysis in place analysis becomes more important. And in fact, that's what Chris Linus, anyone who's been tasked by Chris Linus knows he moves the goalposts time every time you talk to him. But he now wanted, sort of said the paper should serve as advice to the DACs on what they should do when they move their data to the cloud. What things to take into consideration? Do they make another copy in a cloud optimized format, or do they build services around their data in place? And that's the direction NSIDC is moving with ISAT2, because we're NSIDC is creating these OpenDAP sidecar files, these DMR++ files, that allow you to address specific parts of the HDF files, specific chunks, without having to open the entire file. So it makes it somewhat cloud optimized.
This is Jenny Hewson, and I wanted to thank Luis very much for that comment. So I am very new to the ESO team, and the idea of standards and formats, particularly in terms of kind of user access, is something that is very close to my heart. Prior to joining this team, I worked with developing country governments, and one of the major considerations there was really around data access and data usability for this really broad user base. And so how that is enveloped into the way that ESO moves going forward, I think it is a key consideration. So thanks very much, Luis, for kind of highlighting that.
All right. Anything else for Siri Jodha? Denny, you got something else? Oh, maybe not. All right. Well, this has been fascinating. I mean, we learned all about all the different things going on in data. We do all this data management here, but there's all this stuff behind it, right? In terms of standards and things like that. And Siri Jodha has been all over it. So this was great. Siri Jodha, I guess you're going to be back, what, next week or something like that? You'll be in the office soon. Yeah. So we'll see you there. And thank you, everyone, for coming to another exciting CPT talk. So we'll all talk to you again. Farewell.
Bye-bye.
Live long and prosper.